I welcome the participants for today's session of the internship program. I am very much pleased to meet you all in this internship program during this lockdown. I hope this program will enlighten you with various renewable energy sources. In Tamil, we have a proverb, Adikathil Amiyum Parakkum. Yes, it is true. Now we are in that windy season. Today, we have a glance about a green, clean energy, that is wind energy. Our topic is wind power for energy progress, a vision, and present and in future. Energy resources are broadly classified into two types, conventional and non-conventional energy. Wind energy comes under non-conventional source. On account of continuous industrial development clubbed with depletion of fossil fuels and increased environmental pollution, human society today faces multiple challenges for a sustainable development. An alternative way of meeting global demands is the use of renewable energy sources, including solar, wind, hydroenergy, and biomass energy. The demands for alternative energy resources have been increasing exponentially in the 21st century. Being an affordable and clean energy source, wind energy is considered to be one among the renewable energy forms. Wind energy is a very important contributor in the global sector today. It contributes nearly 4% of overall electricity generation. This achievement is the result of exponential growth in wind power development across the world, particularly in the last decade. Wind power is clean, emissions-free power generation technology. As per Global Wind Energy Council, wind power could reach nearly 2000 gigawatts by 2030. It also saves over 3 billion tons of carbon dioxide emissions annually, which is the major cause of global warming. As we all know, wind energy is a form of solar energy. Generally, we can say that the cause of wind energy is the uneven heating of Earth's surface by the sun. Earth's surface is made of different lands and water areas, and these varying surfaces absorb and reflect the sun's rays unevenly. The warm air rising yields a low pressure on Earth, while the cooler air moved down produces higher pressure. Wind caused by a difference in pressure from one area to another area on the surface of the Earth. Air naturally moves from high to low pressure, and when it does so, it is called wind. Wind turbines can be constructed on onshore and offshore. Offshore wind is typically much stronger than onshore, resulting in increased power potential and efficiency. But the installation and operation maintenance costs are much higher. Also, it has a very shortened turbine life. People are familiar with onshore wind. The infrastructure necessary to transmit electricity from onshore is less expensive. Generating electricity from onshore wind turbines cost half the cost of offshore wind and quarter of the cost of solar photovoltaic panels. Here comes a few guidelines for selecting wind energy sites. So the wind energy site should have high annual wind speed area. There should not be any tall obstructions for the radius of 3 km. It should be open plain or open shore. It should be nearest to the load center and to the road transportation. Wind turbine convert the kinetic energy in the wind into mechanical power. A generator can convert mechanical power into electricity. Wind turbine is opposite to that of a fan, since wind turbine converts wind into electricity and the fan converts electricity into wind. Some people use the terms wind and wind turbine interchangeably, but there are important differences between these two. People have been using windmills for centuries to grind grain, pump water, and to do other work. Windmills generate mechanical work, but they do not generate electricity. Modern wind turbine convert wind kinetic energy into electricity. Types of wind turbines. There are 4 types. Horizontal axis wind turbine, which we commonly see. Second one, the vertical axis wind turbine. Third, small wind turbines, which is used for residence. Fourth one, future wind turbine, that is the airborne wind turbine. We can see the diagram of horizontal axis and vertical axis wind turbine. So the major differences are the gearbox and the generator are placed at the top in horizontal axis, and whereas it is placed in the bottom of the wind turbine in vertical axis. Horizontal axis wind turbines are the most common type used. When the wind hits the blades, the turbine that are connected to a shaft cause rotation. Small wind turbine can produce 40 watt to 20 kilowatt depending on the amount of electricity we want to generate. A typical home uses approximately 10 kilowatt hours of electricity per year. Small wind electric system can lower our electricity bills by 50 to 90%. So already in the previous slide we have seen how the wind turbine works. So here we are going to see the cut-in speed of a wind turbine. It is about 7 to 9 miles per hour, and the rated speed is 25 to 35 miles per hour. The cutout wind speed is about 55 miles per hour. When the turbine reaches the cutout wind speed, the turbine shuts down to avoid the damage. So these are the main components of wind turbine. You can clearly see the components in this picture. When the wind blows past a wind turbine, the blades capture the wind kinetic energy and rotate, turning into mechanical energy. This rotation turns an internal shaft connected to a gearbox, which increases the speed of rotation by a factor of 100, that spins the generator to produce electricity. Here comes a video for your better understanding of wind turbine working.
Wind energy is becoming very popular with the growth of clean energy. It is a reliable source of power for a significant percentage of the population that has limited or no access to grid electricity. For a planet already suffering from the effects of climate change and environmental pollution, wind energy can be a green and clean solution. Let's understand how a wind turbine produces electricity. But first, do you know what is wind energy? Simply put, wind is moving air that contains kinetic energy, and the wind turbine converts this kinetic energy into electricity. A wind turbine's most prominent components are its blades. Most turbines usually have either 2 or 3 blades. The hub and the blades together form the rotor, while the main body of the turbine, sitting on top of the tower and behind the rotor, is called a nacelle. Inside the nacelle is the heart of the turbine, which consists of the low-speed drive shaft, the gearbox, the high-speed drive shaft, the generator, and the wind charge controller. Behind the nacelle is the anemometer, a device that measures the wind speed, and the wind vane, which measures the wind direction and orients the turbine accordingly so that the blades face directly into the oncoming wind and captures the maximum amount of energy. When the wind hits the blades, they get lifted and rotate around the central hub. In most large modern turbines, the blades can swivel on the hub at the front so they can meet the wind at the best angle. As the blades rotate, the rotor spins, capturing the kinetic energy from the wind, and this turns the low-speed drive shaft, which rotates at a slow speed of 10 to 60 revolutions per minute. For large turbines, this speed is much too low to produce electricity, and hence it is necessary to increase the turning speed of the low-speed shaft, which is done by the gearbox. Smaller wind turbines that operate at lower wind speeds to generate small amounts of power do not need a gearbox. These are called direct drive systems and are usually less than 10 kW in capacity. When present, the gearbox is used to raise the speed of the high-speed drive shaft by over 100 times, which rotates at about 1500 revolutions per minute. The high-speed shaft is connected to a generator which converts the kinetic energy from the spinning shaft into electricity. The electricity produced is in the form of wild alternating current, which is unusable in this form because of highly variable voltage and frequency. The wind charge controller smoothens or stabilizes the alternating current and converts it into direct current. The direct current produced then flows through a cable running down through the inside of the turbine tower and is connected to an inverter, which again converts it into usable alternating current. Wind power is one of the lowest priced renewable energy technologies available today. The average lifetime of years. Wind turbines can be built on existing farms. The produced electricity can be used locally, fed into local substation, power grid, or to nearby buildings and communities. This is how wind energy is used to light cities, villages, industries in a clean and sustainable way.
N wind is equal to half rho A V cube. So rho is nothing but the air density, V is the velocity, and A is the area swept by the blade. So it is given by the formula A is equal to pi r square, where r is the diameter. Power coefficient is given by output power divided by input power. So there are some disadvantages of wind energy. That is, the wind energy is intermittent, that is, it fluctuates. It generates electricity only when the wind is blowing and at sufficient strength. Another criticism is that species such as birds and bats may also be affected by wind turbines. Some emissions are created by the manufacture, transportation, and installation of wind turbines, but these are considered fairly low. So wind protection in India is about 21% of the renewable energy sources. So electricity generation by the source in India for the year 2018 to 19 is 62 gigawatts of wind power is produced, that is about 4.5%. So the growth of electricity consumption in India is shown in the table. We can see the consumption is increased as the year increases. Wind power generation capacity in India has significantly increased in recent years. As of 29 February 2020, the total installed wind power capacity is about 37 gigawatts. India occupies the fourth largest installed wind power capacity in the world. Tamil Nadu has become the leader in wind power in India. Muppandal wind farm is the largest wind power plant in India of capacity 1500 megawatts. Tamil Nadu's wind power capacity is about 29% of our country's total. The growth of Indian wind power can be shown in this graph. These are some of the onshore wind potential of a country. We have about 8 windy states like Andhra Pradesh, Gujarat, Karnataka, Madhya Pradesh, Maharashtra, Rajasthan, Tamil Nadu, Telangana. Future wind turbine. Normally, the conventional wind turbine work at low altitude below 400 feet, but at low altitude wind has low speed and it is non-steady. But the future wind turbine, that is the airborne wind energy system, AWES, is nothing but airborne wind energy system, work at higher altitude of about 600 to 1000 feet, and at higher altitude wind has high velocity and is turbulence free. So classification of airborne wind energy is about 4 types: ground based power generation, onboard power generation, multiple wing system, lighter than air system. So advantage of airborne wind energy system is they can be placed closer to demand centers, reducing transmission line cost and transmission line losses. It can operate in wind speeds between 5 to 65 miles per hour. They can be raised to higher altitudes without having to build an expensive tower. They can be easily moved to different locations. So Mars is one of the airborne wind energy system. It is nothing but Magen air rotor system. So the Magen air rotor system is a lighter than air tethered wind turbine that rotates about horizontal axis in response to wind, generating electrical energy. Helium sustains mass and allows it to ascend to higher altitude than traditional wind turbines. Wind vane stabilizer. Mars has wind vane stabilizer. They are attached on both sides of the axis to keep the device stabilized and positioned within very controlled and restricted location. Lifting mechanism of Mars. So the helium gas creates a lift force that is in excess of total weight of the system, and also there is an additional lift which is created when the rotor is spinning in a wind. So the advantages of Mars over wind turbine is no extensive setup is needed, less noise than the conventional wind turbine, lower handling and transportation cost, can be installed anywhere and no location constraint, lower transmission loss. It is about 40 to 50% cheaper energy. So as the wind increases exponentially, wind energy increases exponentially with altitude. That is, when the wind speed increases, the power availability by a factor of 8. Application. This mass can be used in mine site, remote exploration and remote islands. Limitations. Mars unit cannot be installed within 5 miles of a boundary of any airport. Initial cost is high. Helium gas leaks at the rate of 0.5% per month. So the drawback of the technology is that the balloon has to be refilled with helium every 6 months, seeing as the gas leaks. Another disadvantage of floating windmills is that they have to be taken down extremely powerful winds, whereas common wind turbines are simply shut down. Conclusion. This kind of technology can reduce our dependencies on fossil fuels, which are depleting at rapid rate. As there is no pollution in this system, green energy can be produced which can reduce greenhouse gases. As it can be near demand centers, cost on power lines is reduced. If this technology is implemented, it can eliminate power problems of all our nation in the upcoming years. Here we have shown the load table for a typical house. It's about 15 kilowatts daily usage. As per Gandhiji's quotes, if we limit our energy needs without any greed, energy can be saved for future generation. Thank you one and all.